Hello students, Miss Slyman here with your next video. So first of all, let's think about, I should have erased this. Well, I'll just talk about it. So sometimes we want to know whether we're going to have zero or no solutions is the same thing. So 2, 1, or no solutions. So we're going to use the discriminant of the resulting quadratic. So the resulting quadratic, like we saw above here, when we solved our initial system, we set this equal to each other and then rearranged it to just have one quadratic equal to 0. Well, based on the discriminant, I can know how many solutions there are going to be. So if I rearrange this quadratic, I'm going to move this to the other side. So my x terms are going to be b minus m x's. My constant term is going to be c minus d. So then my discriminant is going to be b minus m squared minus 4a times c minus d. So let me see if I can move things over a little bit here. Oh, that didn't help me. I want to move this over. In the quadratic situation, when I move all of this over to the other side, I'll have a minus p x squared terms, b minus q x terms, and c minus r as my constant. And of course that's going to be equal to 0. And my discriminant then will be the middle term squared minus 4 times my leading coefficient times my constants. But let's look at it with numbers. So for which values of m are the lines, so we don't know yet if it's going to have 1 line or 2 lines. Is the line mx minus 2 tangent? So that means meeting at one point, remember. So one solution, which immediately makes me think discriminant equals 0. But first, let's think about this picture. So we've got this 3x squared plus 5x plus 4. So I'm going to look at that in Desmos. And I've already put that in, 3x squared plus 5x plus 4. So let me move this down a bit. And now we're going to put in a line, y equals mx minus 2. So I'm going to put in my slider for m. So I want to know how many times this line is going to be tangent to this curve. Well, I can see that at some point, for some positive value, I'm going to hit my curve at only one place. So I need to make my slider go further. So let's go up to 20. Okay. So somewhere around here, looks like around 13, I'm going to hit once. But there could also be another line over on this side. So I could have a negative line. It looks like it hits about there, maybe at about negative 3.3. So I should end up with 2 solutions. So let's go back and look and see if we can find those 2 solutions. So we're going to have that these things are equal. So mx minus 2 equals 3x squared plus 5x plus 4. I'm going to set it equal to 0. 3x squared. 5 minus m are the x terms. 4 plus 2 is 6. And now my discriminant, 5 minus m squared minus 4 times a times c. So 12 times 6 is 72. 5 minus m squared minus 72. And now I've set up here, I want my discriminant to be equal to 0. So I'm going to make this equal to 0. I'm going to get rid of these extra equal signs. So now I'm going to solve this by squaring, the square rooting method. So I'm going to move my 72 over. Square root both sides. I would like to point out that 72 is the same as 36 times 2. So now when I square root both sides, I've already got my solution there. So let me just get rid of it. All right. So 5 minus m, I'm going to square root both sides, get plus or minus square root of 72, which is same as square root of 36 times square root of 2. So 6 root 2. I'm going to move over my 5. Oops, 6 root 2. So 5. Here, when I divide by the negative, that's going to change to minus plus, but it doesn't matter. Those are 2 answers. So let's go back and look at that in Desmos. So if my m value, I don't know if it's gonna like this, but let's try. 5 plus square root of 2, but we said 6 square root of 2. And sure enough, it looks like we have just one tangent. And if we tried the minus, there's our other tangent. So super interesting how this looks. And somewhere there should be my point of intersection. I don't quite see it. So that's great. There we go. 2 solutions. And that's our part A example 2 notes.